Hello, everybody. Let's continue with this example of checking solution. So this time, the solution that we're looking for is of the form y equal to t to the r, where r is some number. And the question asks you, what my possible value of r so that it becomes a solution? So I'm going to do number 19, and you can try yourself number 20. So let's start with number 19. So the form of the solution is y equal to t to the r, where r is some unknown number. So this is number, not variable. So there may be some number so that t to the power r will be a solution of this differential equation, number 19. So let's actually substitute this y into the differential equation and let's check. So number 19 is a second order. So I have to figure out the first derivative and the second derivative. And the power rule from your calculus 1, y prime is r t to the power r minus 1. R is a number. It's an unknown number, but it's a number, right? The second derivative, exactly the same way, using the power rule, I get this. Remember, r minus 1 minus 1 is r minus 2. That's I have in the exponent. So let's substitute this into the differential equation. So in place of y double prime, I substitute this. In place of y prime, I have to substitute this. And in place of y, I have to substitute this. So can we do that? Yes, we can do it. So let's do it. Always remember that you can do it. So that's the motto of our class. So let's do it. So I get t square times y double prime so that's my y double prime plus 4t times y prime, and that's my y prime, minus 2 times y, and it's supposed to be 0. So I want to make sure for what value of r the whole thing on the left hand side become 0. Okay, let's do some algebra. I can multiply this out. So let me copy r times r minus 1, and when you multiply, you add the exponent. So r minus 2 plus 2 is actually just t to the power r. Plus, same way, I have an invisible 1 here. So when I add the exponent, I get, so first of all, let's copy 4r, and I get t to the power r, because 1 and negative 1 will cancel out. Plus 2t to the power r equal to 0. Wow, it's a magic. Look at here. T to the power r, actually a common term. So I can actually factor out t to the power r as a common factor. So let's do that. So I'm factoring out t to the power r. I get 0. Let's look at t to the power r. Because t is bigger than 0, how I know t is bigger than 0? Go back to the question, right? They told you that t is bigger than 0. Because t is bigger than 0 and we're only interested in the real number, not complex, so this cannot be 0. The only way this can be 0 if this factor is 0. So let's multiply out and let's try to solve for r. So when I multiply out, I get r squared minus r plus 4r plus 2. That must be 0. So that's r square plus 3r plus 2 equal to 0. Combining the like term here, that's a quadratic equation. You can use quadratic formula or try to factor out. So in this case, I can actually factor out. So I get r plus 1 times r plus 2. So this actually give me two solutions of r equal to -1 from this factor and r equal to -2 from this factor. So I get two possible value of r, so that t to the power r is a solution. So let's actually write that down. So one of them is y1 equal to, remember the solution have the form y equal to t to the r. So I'm going to substitute r equal to -1, and that will be y1. So that's one possible solution, which I can also write as 1 over t. Another one, let's call it y2, and that's t to the power -2. I substitute r equal to -2. And that's another solution, which is also 1 over t squared. So both 1 over t and 1 over t squared is a solution to this differential equation. And that's actually a good technique of solving differential equation, right? You guess the form of the solution. Here we're guessing that the solution might looks like t to the r, and we substitute and try to figure out what possible number of r I can have. If you look at the previous examples that we did, we guess the form that the solution looks like y equal to e to the rt, and we substitute and figuring out what my possible value of r. So you guess the form of a solution, and you have some unknown number r in your guessing. It could be sine of rt, ln of rt, or some other form, and you substitute into the differential equation and see if it is possible to find a value of r. So that's a trial and error method if you want. You try to guess the solution and then you substitute and figure out the r. But it is not a very practical method, but it will work time to time. Okay, always remember, you can do it. Bye bye.